Hello everyone, it's Groundhog Day. And you're wondering, well, so what? Well, in my own personal opinion, I think, speaking personally, that there are three pretty good reasons for celebrating Groundhog Day. The first reason, obviously, is that it means there's only 6 more weeks of winter to spring. That's a great thing. Weather's going to get better, flowers are going to bloom, and spring is always a great time of year. The second reason is that at Groundhog Day every year, my hockey team is always near the top of the standings, and we actually have time to watch them. If you folks really think that any of you need to watch hockey in the spring, I got a little bit of advice for you. Just become a Bruins fan. It'll make it a lot simpler. The third reason we like to honor Groundhog Day is because it is the middle of the winter agronomy meeting season, and you can count on every year there is one topic that is always close to the top of the heap in the time spent. And this year was no exception. At the Southwest Ag Conference back in the first week in January, this topic was part of 5 out of the 52 presentations. In other words, 10% of the time was spent on the one single topic of nitrogen management in corn. It's obviously pretty important. I think that it's incumbent on me to share a few things from those presentations to bring it to you. And what I'm trying to do is boil it down and keep it fairly simple, fairly straightforward. So here we go. Russ's Nitrogen Management on Corn, Part 1.
Any discussion on nitrogen corn always starts with what's the right rate. Bill Dean did a lot of work at the University of Guelph looking at this very topic. And to put it simply, 8 years out of 10, when you consider the price of nitrogen, the price of corn, you'll max out on dollars per acre somewhere between 160 to 180 pounds of applied nitrogen. My own experience would indicate that's pretty much how it works. And I know what you're going to say. The question you're all going to ask is, well, what rate of N was he actually using, and what yield level was he actually achieving over these years? And I think that's exactly the point. If you're growing corn on the nice silt loam grounds south of the St. Mary's, where you've got lovely yield potential in a given year that's over 200 bushel, you easily can put on 190, 200 pounds of N to try to maximize yield. However, if you're on that flat clay close to the cement plant outside St. Mary's, where it won't yield any more than 160 bushel on a good year, there is no point in putting 200 pounds of N on a field that only has 160 bushel yield potential. Now, if we're going to manage that nitrogen effectively, there's one cardinal rule. All nitrogen, regardless of form, urea 28%, anhydrous, to maximize the amount of nitrogen that you retain in the soil, it all needs to be incorporated. John Lozon at the University of Guelph gave a really nice presentation on what happens when you leave nitrogen on top of the surface. And think about it this way. This year, a number of you are switching to urea because of the price differential between that and 28%. So we're going to use an illustration of what happens when you lay a granular of urea on top of the ground. Think about it this way. It's put yourself in the scenario. It's warm, first week in May, ground's dried nicely. You've got the first cultivation across, and the fertilizer spreader shows up the next morning. Your custom applicator shows up the next morning, broadcasts urea on top of the ground. You maybe had a breakdown problem in the barn, and you don't get out there as quick as you'd like to get that urea worked in. What actually happens? Well, that urea granule sitting on top of the ground soon starts to take a slightly different shape. In simple terms, what happens to that granule of urea is it basically starts to dissolve. And through a process called hydrolysis, the urea compound is transformed into two compounds. One is ammonium and the other is ammonia. The ammonia obviously is a problem because it quickly will volatilize off into the atmosphere. You don't lose a lot of nitrogen in this regard, but given the price of N, I don't think it's hard to understand that any loss is a pretty serious loss. By covering that granule of urea under half an inch to an inch of soil, when that same hydrolysis process commences, any ammonia will not go into the air. It will stay within the soil profile and will then be further converted to something that you can really use, and that's plant available nitrogen. Now, those of you that like putting on all your nitrogen at planting time, working it in nice and neat, are just right now thinking, that's exactly why I do it that way. I want to retain all that in the soil, and then that job is done. And there's no question, on a dry year like we had this past year, that nitrogen is going to remain in the upper part of the profile of the soil. It's not going anywhere, and it's ready for the plant to use. The flip side of that coin is you can have all the nitrogen in the world ready to go, but is the plant actually ready to use it? This chart here illustrates the way corn takes up nitrogen through the growing season. It's expressed up the left side as a percent of the nitrogen uptake. Along the bottom is the time scale throughout the growing season. And the real only point I want to make is that prior to that V7 to V8 stage, which on a year, if you planted on the 1st of May, V8 is going to be more or less the middle of June. So it's all well and good if you put all of your nitrogen on the 1st of May. It's sitting in the profile. It's all ready to go, ready to be taken up. But the potential problem is that the corn plant isn't ready to take it up, and it's not ready for another few weeks. I once heard Chris Hatfield talk, and during his presentation, he talked about while he was in training, the experiments he was running, the things he was learning to do, everything would be going along just perfect. But he said the most important question he always asked himself when he was in the middle of this exercise is what could possibly go wrong? And that's the question that if we have all our N up front and the corn plant's not ready to take it up, what could possibly go wrong? And there's really only one answer to that question. Well, I know to no one's surprise that it's certainly the answer to the problem, the question posed. It is flooding. Now, in a future version of Hot Takes, I'm going to talk a bit about climate change and how it affects the risks of weather events, localized weather events. But for the time being, the effect of surplus water in a soil profile that contains a large amount of available plant nitrogen, you're going to have the nitrates flushed out through the tile lines. You're also going to have denitrification bacteria taking the nitrates and converting them into nitrous oxides, which are lost to the atmosphere. And there's not a darn thing that the corn plant can do about it. I want to wrap this up just by making the point that flooding later in the season isn't the same problem. If you get heavy rainfall in the month of July, that corn plant has a large requirement for nitrogen, has a large requirement for water at that time of year. It's got a big root system, so it actually will intercept those nitrates as they get flushed through the soil profile and use them up to support the growth of that rapid vegetative period, that rapid nitrogen uptake period. So the effect of late season flooding isn't nearly the same as it is during the first 30 days of the corn plant's existence.
Well, if you've stayed with me so far, you are probably thinking, I think there's a little more to it yet. And you're 100% right. We haven't talked about the role of stabilizers in nitrogen management, and we also haven't really dove very far at all into managing split N with respect to corn. That's going to be part 2 of our series on nitrogen management. Thank you for watching. We're going to be back again.